Well, that's the bell, and hey, this is Horner. That was interesting. So this is the lab that you're going to do today, and you'll want to go to Canvas. Already have Canvas open here. You'll see there's some notes for the lab that I'll make another video for. There's a spreadsheet and a report sheet. So I would open up the spreadsheet first so that you have the spreadsheet. There are two tabs on the spreadsheet. Make sure you see that there's a force versus distance, and there is a force versus charge. So you want to see both of those. The force versus distance is the one that you want to have up first. And notice that you're going to create a graph. You're going to create a second graph and then a third graph. So you're going to linearize this 2 times. But let's go back to the Canvas page, and you'll see there's the report sheet. This has got both the instructions and it has the place where you can enter all of your values. So you want to make sure that you do that. It says open the app to start. So you want to click on the app itself, and we'll open the app. So in this lab, or in this program, you're going to be looking at some factors that affect how two objects that are charged the same, so they repel, and these objects are called pith balls. They're kind of like cork, I guess you could say. And when they get a charge and you attach them with a thread, then they will repel each other. So probably the easiest thing to do to get started is just start kind of reading the directions. So the very first direction here says using the app set charge 1 to the smallest value. So you'll go into charge 1, and then we're going to make it go down to the smallest value. You'll notice that that is 0. You'll want to click up 1 time, and it will give you a new value. So you've got that value now, and you'll enter that value in the spreadsheet. Now be really careful, because this says Coulombs, and you want to make sure that yours is in Coulombs. This is in Nano Coulombs. To convert to Coulombs from Nano Coulombs, the instructions are on the sheet, and you want to make sure that you have it in scientific notation. For the other charge, you're going to do the same thing. So you're going to go to charge 2. You want to knock it all the way down and then pull it back up so that it has a value. Please do know that both you and the people at your table will have different values. So make sure that you do this on your own. Alrighty, now that they both have a value, the next step in this is to make sure that you record the mass. You'll do that in milligrams and then in kilograms. There is a grid on the inside of the app, and so you'll want to say show grid, and then you'll also want to say show angle. At this point, it's really hard to see what's going on between the two, so if you just click on the word charge 2 and on charge 1, those will disappear. The next step in the lab, they want you to move the charges so that they are 0.31 meters apart. And so I'm going to move this charge to the left, and I can move this charge to the right a little bit. You'll get to a point where you can't move the right charge anymore, and you'll have to move the left one. They're now you'll notice that the graduations here are 1, and now I'm at 0.31, and I've got to measure the angle. So you want to do it to the nearest half angle. So this one for me looks like it's at about 5, 6. This is 7.5 or so. So that's a judgment call on your part. When you enter that in, you're going to enter the angle, and you'll enter the distance. The force of electricity is going to be different. So the force of electricity, you'll have to watch the other video to see what's going on. In that other video, it will tell you how to find that force of electricity. So make sure you watch the other video also. Once you've done that, then the next thing you're going to do, because in this first step we are doing change in position, we're going to reduce the distance between the two charges by 2 centimeters. So essentially all I'm going to do here is, it's probably easier to move the left one, and I'm going to move it over by 2 centimeters. And you can just get as close as you can. Notice that this is not going to be perfect. And then you're going to read the new angle, and then you're going to continue to do that. So that is the first part of the lab. In the second part of the lab, you're going to go through and look at force and charge. So this time they want you to record the initial angle. You're going to put the original values on, and then you're going to increase charge 1 only by clicking that up arrow. When you do that, then you're going to end up seeing what happens. So just really quick to show you how to do that, let's go ahead and just put the two charges at a set distance from each other. So I'm going to move them in so they're about 25 centimeters apart. And then I'm going to record the value, and then I'm going to change charge 1. So I'm going to increase it, and I'm going to read the new value, and then I'm going to increase it again, and I will read the new value. You have to be careful. You'll notice that they are no longer 25 centimeters apart, so you'll have to continually adjust where it is so that they stay at the same distance. If they don't stay at the same distance, then this lab will not work very well, so you'll have to kind of watch out for that also. Those are some tips and tricks. One thing that I can tell you is you will get a graph and you will see a little bit of a curve. You'll plot it, and then it might look straight. It actually is a curve. So you will need to linearize that. I'm going to go ahead and tell you right here, since you're watching this, that the second time you linearize, you're going to want to treat it as a GROUT. So I'm going to just type GROUT in here and make sure that you notice that whatever graph you have here is a GROUT. And so you'll need to go ahead and take the data that you have in this spot and modify it so that you get that data over on this side. And that really should be it. As you move down on the lab, you'll notice that it says write a physics equation, then write a general equation. The physics equation for the straight line should just be right off of the graph, and that should be really easy. The general equation, on the other hand, is going to look something different. So you're going to have something here. It's probably the force of electricity. And then you're going to say that it is proportional to something. I can give you a little hint. It will be 1 on the top, and then you're going to have something on the bottom. Both equations should look similar to this, and that's what you will see. But other than that, that should be pretty easy to do. So I'm going to get out of the draw and zoom. Okay, so now we will get out of draw and zoom. All right, so now we're back. For the final analysis, you have two general equations. You're going to combine those. So you will have Fe on the left side, and then put the two things together that you have on the right. Okay, so you'll have to kind of go through and figure that out. If you need help, what you should do is go look up the actual equation for the force of electricity. Type in Coulomb's law equation for AP Physics 1. You could also just look on the AP Physics 1 equation sheet. They want to know some units and things, and then you have a problem that you will need to do using that equation that you looked up. I think that should be about it. Make sure you watch the other video on the forces that occur in this lab. If you don't watch that, you will have trouble trying to figure out some of the things that you need on your spreadsheet, mainly the force of electricity. That's it.